All right, I think we're live everywhere except TikTok. Appreciate y'all joining so far. Now we're live on TikTok. Doing another coding challenge tonight. Another easy problem called Unique Number of Occurrences from Leetcode.com. I'm going to give people a few minutes to join, give everybody some time for everything to connect. But appreciate you guys joining across Instagram, TikTok, YouTube, Twitch, and Facebook. I'm everywhere, so if you want to switch to another platform, you can. But yeah, I'm not about to take too long. I'm about to hop into this pretty quickly here and try to get through it since it's an easy problem. Hopefully I can get through this pretty fast. I'm going to try not to get too distracted. So please bear with me with the questions and comments and stuff like that, because it's hard to do this code and concentrate and answer the questions at the same time. But I'm going to try my best. So without further ado, I'm going to jump right into this problem. This problem is from Leetcode.com called Unique Number of Occurrences. It's a coding challenge from Leetcode.com. It's an easy. They say that it's asked by Amazon, Adobe, and Google, some of the biggest companies. And it goes as such. Given an array of integers R, return true if the number of occurrences of each value in the array is unique, or return false otherwise. So here we have an example of an array with 1, 2, 2, 1, 1, and 3. So we see some duplicates in here. And the output is true because the value of 1 has 3 occurrences, the value of 2 has 2 occurrences, and the value of 3 has 1. No two values have the same number of occurrences. So the number of duplicates is different for every type of number, if that makes sense. And in here, it's false because you have 1 occurrence of 1, you have 1 occurrence of 2. So you have 2 occurrences of 1 occurrence, if that makes sense. So the answer is false. You don't have a unique number of occurrences, which is the name of this problem. So they have some constraints down here where the array is not going to be longer than 1,000 characters, 1,000 items in the array here. And then each item in the array is not going to be less than 1,000 and not going to be greater than 1,000. That can be important depending on how you do the problem. I'm not sure it's going to be important based on how I do it, but I think the constraints are always important for sure. So if anybody's ever watched me do these before, you know that how I like to do these is think through the problem in my head. Sometimes I write stuff down, sometimes I don't. But think through the problem in my head. How would I do it just in my head, trying to solve it, or on paper? And then take that solution and apply programming concepts and data structures and algorithms that I'm familiar with to solve the problem. Like take the problem from my head to code. So looking at this problem, when I see, based on the history of doing these problems, when I see number of occurrences, one of the first things I start thinking about is using a map. And I think about frequency. So I think about I need to store the number of these occurrences somewhere. And so if I'm thinking about how to solve this problem in my head, I would do a loop, and I would loop through each of these numbers, and I basically would store it in some sort of data structure to keep track of how many times each of these numbers got hit. So basically I would see 1, I would say, okay, I saw 1 one time. I would see 2, okay, I saw 2 one time. I'd see 2 again, okay, I saw 2 2 times. I see 1 again, okay, I saw 1 2 times. I see 1 again, okay, I saw 1 3 times. So I would store a mapping of 1 to 3 because I saw 1 3 times. I stored a mapping of 2 to 2 because I saw 2, the number 2 times. And I would store this in some sort of data structure. If I was writing this down, I would just write it down. And then when I got to the end, I would see if everything that I stored, if none of them equaled, if all of them were unique. So I would get a unique number of occurrences, because what I stored is the number of occurrences. It's the frequency. So that's how I would do it in my head. I hope that makes sense. And so without further ado, I'm just going to jump into the code, because this problem isn't supposed to be one that I ponder on too long, because I have a notion for doing that in some of these, and the videos go really long, which I don't want. So I'm going to jump right over into the code. And for anybody just joining, the name of the problem is here. The problem description is here. And so I'm going to start jumping in this. So what did I say I was going to do this how I was going to do this when I was thinking through it? So I said I was going to store everything inside of some sort of data structure to store the frequency of every number that I see. How many times did it occur in the array? And so to do that, that's going to be a loop, and that's going to be putting everything into a data structure. So thinking of time complexity and space complexity, I'm going to loop through the array once. So that's big O of n, that's linear time. And I'm going to store at most the number of items in the array. And so that will be big O space complexity as well. So big O time complexity, big O space complexity to do this first part. So let's run through this first part. So what I need to do is, I already said I need to set up a data structure to hold my frequencies. And so what I want to use, I'm using JavaScript to do this problem. And what I'm going to use is a JavaScript map to store it. A map is a key pair value storage system that allows for me to quickly access the key and value based on the key. So yeah, let me try to do that. Sorry, I'm trying to read comments and everything as well. Yeah, map is similar to a dictionary. And so what I can do here is start looping through my array. And so when I start looping through the array, I can basically say, look at my map. And this is how maps work in JavaScript. I can see if I can use this hash function to see if this number. So when I loop through the array, I get each number of the array to do some sort of processing action on, if you don't know what a for loop is yet. And so basically I'm saying, does the frequency map already have a key for this number that I'm looking at? If it does, then I want to set this number equal to, and so I also need to get the old number out. So I can say get num, and this might look a little confusing, but I'm going to explain it. So basically I'm setting the frequency, the new number to the same number. I'm going to add 1 to the current frequency. So I'm just taking out the current frequency and then resetting it again by adding 1 right here. And else, and I probably should have did this case first because it may make more sense to people if they're confused. But if it's not, if I go into the other case and it's not in there, then I need to just set it equal to 1. So these are my key value pairs. I put num, and this is how many times I've seen it, 1 time. But up here, if I've already seen it, then I set num again, but I update it with the current number of times I've seen it, and I just add 1 because I've seen it 1 more time and it was already in this array. And so it's already in this map. So one thing about map, you don't want to try to set a map. You don't want to try to set a map that you already. You want to try to do a check to make sure there's already something in the map. Otherwise, you can't get anything out if there's nothing there. You don't want to try to get a value out of a map that hasn't been set with it, or a key out of a map that hasn't been set yet. So that's why I'm doing this kind of if-else logic here to do this. So now that I have this, now what have I done so far? I've made a frequency map. I've taken the array that came in, I looped through it, and I've added all the frequencies to the map. So now I know how many times each number in array has occurred. So I have a key value pair. I have each number of the array, and I have how many times it occurred inside of this frequency map. So then what I said I was going to do, I was going to take the frequency map and I would check to see if there were any duplicates in it. If every single frequency that I recorded is unique, because the problem is called unique number of frequencies. If so, I return true. If not, if I have some numbers that occurred the same number of times, then they're not unique, so I return false. So how can I do that? So I can basically actually loop through, I could say, I think value. I can loop through my frequency, and I hope I'm doing this right. I think it's values. So what this does is take the map, and since the map is key value pairs, I can actually get an array of all the values by themselves without the keys. So right now I don't need the keys. I just need to know if these values are unique. And so when I do this, the biggest this can be is in size. That's if every single because I had to store every single number in my array inside this map. So this loop would be linear as well. It would be big O of n time complexity. Just to keep track of our time complexity as we go through this problem. And so what I would do here is, now I'm looping through my frequencies, and what I want to do here is say, actually I missed the step. So what I want to do here is actually create a duplicate. Let's call this dupes. I want to create a set in JavaScript, and what a set is when you add stuff to a set, the set will only contain unique values in it. But it also has a has function too. I can check to see if something's already in the set. So what I can do with a set, because in the set will give me very fast, like instant, constant, big O of 1 search time of the set to see if a key is there. That's why I would want to use a set instead of using a whole nother array or just checking this directly. So I can say if dupes has, again, value. If it has the value already, remember what we said. We want to return, we have a duplicate. We want to return false. That means the number of occurrences is not unique. So we want to return false. So we can just break out here. We can just end the problem here. Else, if the dupes is not in there, if the value is not in the dupe set, then we need to add it there and continue the loop. So we would do, I think in the set is add, and we would just simply add val there like that. And then down here we would return true. If we got through this without any problems, without getting any falses, then we would just return true at the end of this problem. So this looks about right to me. Y'all let me know what you think. And sorry if I'm ignoring you. And yeah, somebody said, so I do want to talk about the time complexity next. So somebody said, correctly so, that the time complexity would be big O of 2n because I'm using 2 loops right after each other. They're not nested, they're just right after each other. So what that reduces to is, since the 2 is kind of arbitrary, or it's not usually calculated in big O time complexity because it's not, 2 is not tied to the size of my input. 2 is a fixed constant. So it will, so the algorithm, or sorry, the time complexity will reduce to big O of n actually. So this whole time complexity of this problem is big O of n, because I'm simply looping based on my input. If we call the length of array n, let's just call it n, then I'm looping through n times here, and then I'm looping through at most n times here, because my set, or sorry, my map I've only populated with n number of items. So n plus n would be 2n. And so basically the whole problem would take big O of n to be a linear problem in time complexity. Since I made this frequency map and I made this duplicates map, those are both n as well, which would give me 2n in space complexity. How much information did I store? And so I was that still would reduce down to big O of n time complexity. So yeah, so that's the problem. So now I'm going to run this to see what it's looking like. Yeah, got accepted for all cases on Leetcode. So what this does on Leetcode is it's going to run these examples that are over here, 1, 2, and 3. And it simply just runs them with some sort of automation that they have built in. And so yeah, I got true where I was supposed to get true there. For all 3 cases, I basically got the right answer. And so what also you can do on Leetcode is submit it against all other submissions on Leetcode. And so let me do that. Got it right. I beat 70% of all other submissions and 58% on memory and 70% sorry on runtime, and I beat 58% on memory usage. And I believe this is because the way I did it. And I see now that I finished the problem, because I'm going to repost this video later, so I just want to get through the problem. Now I can answer some questions that I see in the chat, which I do appreciate. So let me go back to, how do I get back to the problem? Yeah, get back here and display this for you guys. And then let me move my little screen over here so I can answer some questions. Yeah, so somebody was saying that why not here? Why use a set? Why not use another array? Or why not just check this array? Because checking an array for one value is expensive, because you have to look through the whole array at worst case. When you use a set or use a map, when you look for a key, that's the advantage of sets and maps. That's why you should learn about sets and maps. When you look for a key in a set or map, you get it back in constant time, which is big O of 1, which is constant time, which is very quick lookup. You say, I want what is in key for this map, what is in key number 1, for instance. You'll get it back like almost instantly. Now, if you just have an array and you look for an item in an array, even if you use a JavaScript function or you loop through it or whatever you have to do you have to literally look at every item in the array and try to find it, like find what each one equals to whatever you're trying to look for. So that's why you don't want to use an array here when you're doing this part of the problem. But that's a great question though. And so, looking on Instagram, somebody said a bigger time complexity would be big O squared or big O n squared. I'm thinking that's what you're saying. Big O of n squared. Yeah. So if I was nesting these loops, it would be exponential time complexity. Like for every time I loop through, I would loop through a whole another time. That's why you don't want to you don't want to be searching an array, because that would be big O. That would be like exponential time. It'd be n times n. Instead of just one loop through n, let's say I have 5 items in my array. Then on this problem, I'm basically going through 5 and then I go through 5 again. It's very quick. Now, if I was nesting, if I was having to search the array again inside of here, then it would be 5. And then for every one, I would do another 5 in each one. So it'd be 5 times 5. It'd be like exponential. It'd be n times n. N squared time complexity. Why am I not coding in dark mode? I'm not a crazy fan of dark mode. I like it to switch at night and day. I don't know why Leetcode isn't switching at night and day, but what I like my stuff to switch. Like at nighttime, I like it to go dark, and daytime, I like it to go light. But it is a good question because it's night here, so I guess I might have turned it off on accident or something. So great question. Let me see if I'm missing any questions anywhere. It's still linear. The video seems to be lagging. I'm sorry about that. Let me see. Well, I was saying is a way shorter and more efficient solution. What is it? Let me know what it is. I think that was Keybesh. Let me know what the better solution is. I don't know a better solution than this. So just let me know. Because this solution, now if you're, I think I probably know what you're saying. So another solution you can do is when you put it in this frequency map, you can take the frequency map and you could take these values and you could sort it. And then you could say, do I have any duplicates in the sort, because now it'll be in order. If you straight away add the elements to a set. Yeah, so I see what you're getting at, but and compare the size to array. So KBesh, now let me say this to you. You got a good point there as far as how it'll make the code look cleaner, but think about why my solution is faster than that. Because it is. So what you're gonna do, you're gonna take let's say you have 1,000 in this array. You're gonna put 1,000 items. You're gonna try to initialize a set with 1,000 items when you don't have to. Because here, as soon as I find a duplicate, I'm gonna return. So if you have a duplicate in the first 2 items, my thing will return while your function will still be adding items into the set. So this one at best case is faster than yours. At worst case, it's the same speed as yours, if that makes sense. So it's because I'm exiting out. I'm exiting out when I find a dupe earlier. If I just put this in, so I could just put it in the set here like you said, but that means that set would have to process everything before it even starts checking for a duplicate. I start checking for a duplicate immediately. So that's why I didn't just dump it in the set. I could have, but I didn't, because this is faster. And that's why I got a faster, when I ran it against all the Leetcode solutions, I got a faster time. So that's kind of what, yeah, but you already created a map, which requires it. Yeah, but you'd have to do that in your solution too. You have to create a frequency map, period. You can't avoid this whole top part of the solution. You have to create a frequency map. What you're talking about is doing something different down here in the set part. You need a frequency map. What I'm saying is that, so I'm going to have to loop through here one time at least. But here, I can avoid looping through everything, because I basically break out of the problem here instead of just trying to populate a whole set. But in an interview, you'll probably be fine. Like, I don't think they would care, but this is a little bit faster at best case. Because let's say I have a duplicate. Let's say my first 2 values are duplicates. Then I'm going to break out after 2 loops. But if you fill up this whole set, now you got to fill it. When you do a initialize with this set, behind the scenes to build that set, it goes through everything already. It just goes through everything to build a set. So you're not saving any time just because you can't see it. It's doing it behind the scenes when you build a set. So you're actually looping here, then you're actually looping here again when you build the set. So I'm not going to build a set yet. I'm going to flip through, and I'm not even going to finish building the set before I loop out. So that's all I'm saying, is that it's faster. And you need the frequency map because you need to be able to count the number of occurrences so that you can figure out if there are any unique occurrences, or if all the occurrences are unique. So you need a frequency. You need a frequency map. If you're going to do the problem like this, there might be other ways to do it without a frequency map, but I don't think they'll be as fast. I mean, I don't see... The only other way I know to do this problem is you build a frequency map still. Then you can sort the frequencies in this frequency map, sort them in order, and then you can loop through the frequencies, and then you can stop when one frequency behind another are equal to each other. So, yeah. And so you can do that, but that takes more time complexity. Sorting is big O of log n. So that would make this solution n times big O of n times log n. So n log n. So that just makes the solution not as fast. So you don't need a frequency map at all. In the beginning, add the elements to a set straight away and compare the sizes. So then you lose your frequencies. You can't. I'm not sure what you're saying. You have to find the frequencies. If you just came up here and just made a set when you try to add something that's already in the set, then it won't add it, and you won't know. If you add 5 ones, you wouldn't know because the set would just erase it. The set would just ignore it. So the problem isn't is there any duplicates. The problem is unique number of occurrences. Yeah, I think I know where you're confused at, but the problem isn't finding duplicates. The problem is, are the unique number of occurrences. So just because there are duplicates in here doesn't mean that, see, there's duplicates in this, but it's still true. It's not about the duplicates, it's about the number of occurrences. So I think that's where you're a little confused, but it's understandable. Because you have to find the frequencies. You have to find the frequencies. Even in this simple explanation, you have to find the frequencies. So it can get a little confusing. Yeah, see, yeah, it's okay, cause I understand, man. It's like, this is why these problems kind of suck, cause that's why I don't like these problems in interviews. But we gotta freaking do them because people ask them in interviews, and they confusing. But yeah, I think that's where it was. Cause I got confused when I was looking at this problem earlier. When I was deciding to do it on here, I was like, is this just finding the duplicates? And I was like, oh no, it's like another layer of complexity because you actually got to find the frequency, and then find the duplicates in the frequency. It's like crazy, but not crazy, but it's just a little bit more complicated. So appreciate the discussion though, cause yeah, yeah, I figured you weren't in from the beginning, so that's why I slid it back over. So no worries, K-Bash, appreciate it. Like the comments, I think it helped because it helped me think through it, and it also helped me explain stuff to everybody else. So it's no worries at all. Like, this is what we're here for. This is why we're doing this. So yeah, thanks for the questions. Thanks for the comments for sure. K-Bash especially, and everybody else too. Yeah, see, somebody else said I thought we were checking if dupes existed. Yeah, see, if we were just checking if dupes existed, y'all would think I'm crazy. Y'all like, why are you doing all this? Yeah, see, it's a little more complicated. It's like the unique number of occurrences. So even if it has duplicates, it still can be true, because here you have 3 1s, here you have 2 2s, and here you have 1 3. So the number of occurrences in 1, 2, and 3 are all different. It's kind of backwards because you have 3 1s, you have 2 2s, and you have 1 3. So it's kind of like backwards, if you get what I mean. So yeah, this was fun. Appreciate y'all joining, and thanks for all the comments and everything. Somebody said put the problem in Chat GPT. Yeah, I wish you could do that for everything, man. If I was at work, yeah. So this is to practice like logical thinking, data structures and algorithms for interviews mostly is where you're going to use this stuff. Unfortunately, that's how the game goes. It's like a lot of big companies ask these Leetcode type questions, these coding challenges, but even some of the smaller, mid-sized to smaller are starting to ask these too. So I like to do these because nobody really does these much online, that much I've seen. So I like to just jump on here and do these. I'm putting myself out there. It's embarrassing sometimes, but hey, I'm just trying to get out here and do these easy ones first. I've done some hard ones too. They take forever to do on here. They take forever to do anyway. And I've done some mediums, but I'm going to start mixing it up some more. So yeah, appreciate it, man. Y'all follow me. Y'all follow me on all the platforms. TikTok. I'm on TikTok, Twitch, YouTube, Facebook, and Instagram. I stream on all of them when I do these. I'm doing 1 a week right now. I'm gonna try to move up to 2 a week, and I'm gonna try to start streaming other stuff too. But I appreciate y'all. Like, comment, follow. Let me know if DM me, whatever you want to do. I'm here to help people. That's kind of my goal on here. And yeah, so hope you guys enjoyed the problem, and I'll see you guys in the next one. And I'm gonna sign off here.